This is lesson 4.5. In this lesson, you will learn how to solve a quadratic equation by factoring, and you will also learn how to convert between the standard form and the factored form of a quadratic equation. Okay, here are a couple of quadratic equations, and if we were to solve this top equation, the first thing we would do would be to factor it, since we want to solve by factoring. So we divide the x squared into x and x. And to make positive 6, we have 1 times 6, negative 1 times negative 6, 2 times 3, negative 2 times negative 3. And since we're adding up to negative 5, we're going to want negative 2 times negative 3. And these two things multiplied together still equals 0 because it's an equation. So to solve this, we need to have a system or a rule or something, and that rule is called the zero product property. The zero product property says that when you multiply two things together and the answer is 0, then one of those two things was 0. For example, let's say we have 5 times 0, we know that equals 0. If we have 0 times 4, we know that also equals 0. If we have 4 times x equals 0, then we know x must equal 0. Or if we have a times b and the answer is 0, the only way for a times b to equal 0 is if a equals 0 or b equals 0. So on our problem that we're looking at, since we have x minus 2 times x minus 3 and the answer is 0, then x minus 2 must equal 0 or x minus 3 must equal 0. So each of these is just a linear equation and we know how to solve them. We would add 2 on each side to get x equals 2 and add 3 on each side to get x equals 3. For our second equation here, we cannot use the zero product property unless it equals 0. So the first thing we'll do is add 12 to each side to make the equation equal 0. Once we have that, then we can factor it, and to make 12, we have 3 times 4 is 12, so this would be a negative 3 and a negative 4. Since x minus 3 times x minus 4 equals 0, then we know x minus 3 equals 0 when x is 3, and x minus 4 equals 0 when x is 4. So these are our two solutions. Okay, so here are a couple more examples. On this top example, again, it does not equal 0, so we're going to subtract 15. So we get 2x squared plus 7x minus 15 equals 0. And then we want to factor this, and since our leading coefficient is 2, we'll want to factor this using the tic-tac-toe board. So we have 2x squared in the middle, negative 15 down here. Multiplying them together gives us a negative 30x squared, and then we're making a list. So obviously we have 2 times 15, and one of them has to be negative. But 2 and 15 don't add up to 7. So how about 3 times 10? And one of the numbers has to be negative. And we want it to add up to positive 7, so we can choose this combination. So we can put them in here, negative 3x, 10x. Take the GCF for the row, we get negative 3. And for the next row, 2x. For the column, x. For the next column, 5. So this factors as 2x minus 3 and x plus 5. Using the zero product property then, 2x minus 3 equals 0. If we add 3 to each side, we have 2x equals 3. And dividing by 2 on each side, we get 3 halves. 3 halves is equal to 1.5. Or x plus 5 equals 0 when x is negative 5. So we get these two solutions right here. We could solve this same equation by graphing. So I'm going to switch to a graph. Okay, so here's our graph. We want to change our equation to say 2x squared plus 7x minus 15. Okay, there's our equation. And looking at the graph here, we get our solutions at the roots. The roots of the equation are where it crosses the x-axis, and we get one root at 1.5 and the other one at -5, which is exactly what we got by factoring. And here are our factored solutions. Okay, for our second equation, we can solve this by factoring. So we have x and x. 24 is 4 times 6. So if we do plus 6 minus 4, that'll give us a negative 24 when multiplied and a positive 2 when added. So x plus 6 equals 0 when x is negative 6. X minus 4 equals 0 when x is 4. And we could again get these solutions by graphing. Okay, right here I have given you the website for GeoGebra. If you type in geogebra.org/webstart and click on the webstart button, you should be able to graph your functions in GeoGebra and look for your x-intercepts to solve by graphing. Okay, here is an application to this graphing to find solutions. If we have a frog that starts at the origin and jumps according to this equation, we can find how far the frog jumps by graphing it, and then from the graph we look where it hits the x-axis when it lands. So we're going to do that in GeoGebra. At the bottom of the screen here where it says input, we're going to type in the equation y equals negative 0.029x to the second plus 0.59x. When you press enter, it graphs it. So then we need to move the graph around so we can see. So, that's not it. Okay, so here we have the graph sides so that we can see it. So I'm going to put a point on over here, and the point where y is 0 would be the x-intercept, and over here on the side we can see that the x value is 20.34 when y is 0. So if the frog starts at the origin and it jumps, it's going to land over here at 20.34. So it's going to jump that far. So we can say the frog jumped 20.34 feet across. Then how high did the frog jump? We can find how high by doing x equals negative b over 2a, but that will really just tell us the halfway point between the origin and 20.34. So it should be just half of 20.34, which would be 10.17. And then we can plug 10.17 back into the equation for both of the x's, and we get approximately 3 feet. So the height that the frog jumps is approximately 3 feet. If we look at this on GeoGebra, it appears as though right about at 10, the frog is jumping approximately 3 feet. So a reasonable domain and range for this, for a frog jumping specifically, the domain would be from the origin, which is 0, to its landing point, which is 20.34. So our domain is between 0 and 20.34. The range is the height that the frog jumps. So a reasonable range would be from the ground up to the maximum height of 3.